Hello everyone, myself I am Divya from Department of Chemistry, working as Assistant Professor in Marri Laxman Reddy Institute of Technology and Management. Okay, so in today's session we are going to discuss about a topic known as corrosion. Okay, so in today's topic we are going to discuss the corrosion, that is causes and effects of corrosion and the theories of corrosion. First, what do you mean by a corrosion? Okay, the word corrosion is derived from the Latin word that is corrodere, that means to eat away, to eat away. So corrosion can be defined as degradation of metal due to a reaction with its environment, or we can also say a destruction of a metal or deformation of a metal. So when a metal, when it reacts with its environment or atmospheric gases, the metal gets destructed. You can see image below. Okay, so the metal gets destructed or it is deformed. Okay, that we call it as corrosion. Few examples of corrosion are, a common example we know is the rusting of iron and also the tarnishing of silver. So can you see an image down? Okay, before how a nail is there and after corrosion how a rusting of iron takes place. Okay, because of the water and the oxygen in the environment. One more example of a corrosion is appearance of green color in copper. So the reason the Statue of Liberty changed the colors in the outer surface is covered with, why? Because it is covered with the copper sheets. Okay, when copper undergoes the corrosion, it changes to a green color. It is one of the example. First of all, corrosion, how it is caused. We have understood till now what is a corrosion, a simple definition, that is a degradation or deformation of a metal. So how this corrosion is caused? So metal corrodes when it reacts with the another substance such as oxygen, hydrogen or electrical current or even the dirt or bacteria. So these are some of the causes that metal undergoes the corrosion, like water, humidity, weather, dust and salt. Corrosion can also happen when metals like steel are placed under too stress, causing the material to crack. Can you see here picture, that is crack? Okay, a material under crack. So whenever our material is under too stress, it undergoes the crack. Now, effects of corrosion. Okay, so first effect is damage to the infrastructure. How? It can damage the steel reinforced bridges, okay, which are constructed, like bridges are constructed using of steel, and also the highways, parking structures and also the electrical towers. Next, damage to the cultural heritage like in museums. Next, safety issues. Corrosion can lead to the equipment failures. Okay, the metal we use in our missions or equipment, when this metal undergoes the corrosion, it leads to the failure of metal and it leads to the fires, explosions and also the release of toxic products. So these are the effects causing our safety. Water damage. One more effect is water damage. Corrosion can cause pipes to crack. Okay, we use water pipes, iron pipes underground, right? So these undergoes the corrosion and it cracks and fail, and it also leads to the jam and also pumps to fail. Loss of efficiency. One more effect is loss of efficiency. Like corrosion can decrease heat transfer rates in heat exchanger. This we can see in a boilers. Okay, in a boiler, when it undergoes the corrosion, it cannot produce that much efficiency of heat transfer. Okay, so next we have the other topic in the corrosion is theories of corrosion. So under theories of corrosion, we have three types of theories. One is acid theory, second one is dry or chemical theory, and the third one is galvanic or electrochemical theory, and also we can call it as wet theory. Okay, wet corrosion. So by the reaction with acids, okay, it undergoes the corrosion, and under dry or chemical corrosion, or the theory when metals react with the atmospheric gases directly, okay, there you can see occurring of dry or chemical corrosion. Coming to the electrochemical corrosion, when the metals are in contact with the conducting medium or the liquid, then you can see the electrochemical corrosion or wet corrosion. So the dry corrosion, you are going to observe the absence of moisture. Under wet corrosion, you can see presence of moisture. So these are the three theories of corrosion. So coming to the next topic, that is dry or chemical corrosion. So the direct chemical action of environment on the surface of metal. So whenever you have a metal like this, the first affected area of a metal is surface. The first affected area is surface. So the metal surface undergoes the corrosion when it is in direct contact or the direct action of environment. So under environment, we have atmospheric gases like oxygen or chlorine, anything, okay? And by the name, we are saying it is a dry corrosion. So it indicates the absence of moisture, absence of moisture. So this type of corrosion occurs mainly through the direct chemical action of, as I said, oxygen, halogens, okay, H2S and SO2 and N2, etc. So we have three types of chemical corrosion. Those are, first one is oxidation corrosion, second one is corrosion due to other gases, and the third one is liquid metal corrosion. Now we'll see detailedly what are these corrosions actually. So first one, what we said, oxidation corrosion. By the name it indicates when metal reacts with the oxygen, okay, oxygen, it leads to the oxidation corrosion. So this is carried out by the direct action of oxygen at low or high temperatures. As we know, dry corrosion means absence of moisture. Corrosion is initiated in a metal when it is contacted directly with the oxygen. When the metal gets oxidized, the metal ions and the electrons are released, okay, and it reduces the oxygen to the oxide ion. This is how a metal looks when it undergoes the oxidation corrosion, okay. Simply remember, when we have a metal, okay, when it reacts with the oxygen, you can see formation of oxidation corrosion on the surface of the metal, on the surface of the metal. So these are the reactions undergo through the oxidation reaction. That means on metal, okay, metal undergoes the oxidation process, that means loss of electrons. So metal oxidizes to metal ions and it liberates the electrons, okay. So we have a metal plus oxygen, right? So when these both react, you can see formation of oxidation corrosion. So near metal, what is happening? It is an anode, and here oxidation is undergoing. Oxidation is nothing but loss of electrons, okay. So the metal will convert into a metal ions and also the electrons. It liberates the electrons. Now, with what it is reacting oxygen, right? This oxygen will gain these electrons, from the anode, and it will give the oxide layer. Okay, so the metal and oxygen combine to form a metal oxide. So the metal ion and oxide ion combine to form a metal oxide on the metal surface. As I said, metal surface will be affected. Metal surface, the metal ion and the oxide ion combine to form a metal oxide on the metal surface. As I said, the metal surface undergoes the corrosion. The extent of corrosion depends upon the nature of metal oxide. The extent of corrosion depends upon the nature of metal oxide. So remember, if you take a metal like this and when it is reacted with the oxygen, you can see formation of a oxide layer on the surface of the metal. So depending upon the surface of the metal, like oxide layer, we further classify the oxidation corrosion into 4 types. The nature of metal oxide layer formed plays an important role in determination of further corrosion, as I said now. So depending upon the oxide layer, now you know what is meant by oxide layer. Okay, so when metal reacts with the oxygen, you can see a formation of metal oxide layer on the surface. This is your metal oxide layer. So based on this oxide layer, we further classify the oxidation corrosion into 4 types. The first one is stable oxide layer, second is unstable oxide layer, third is volatile oxide layer, and the fourth is porous oxide layer. So if the metal, so the first one is what? Stable oxide layer. So from the name it indicates that the oxide layer formed on the metal surface is stable. So if the metal oxide is stable, it behaves as the protective layer which prevents the further corrosion. So imagine if this oxide layer is very strong or it is a very stable in nature, it will not allow the further corrosion to take place on the same metal again. So this is how you can see a metal oxygen, it reacts, okay, and here this layer is your oxide layer. If that oxide layer is a stable one, it will not allow the corrosion to process it again on the metal. Like further corrosion will not take place. Next, second oxide layer is unstable oxide layer, which is opposite to the stable oxide layer. As we have seen the before slide, if the oxide layer formed is stable, means it will protect, right? So now the oxide layer here is unstable. Okay, so if it is unstable, it will again decompose back to the metal ions and the oxygen, and it will help further corrosion on the metal surface. We'll see. So if the metal oxide layer is unstable, the oxide layer formed decomposes back into metal and oxygen. So oxidation corrosion is not possible. So here the formed layer is unstable, so it decomposes back to metal and oxygen. So again your metal surface is exposed to the air or the atmospheric gases, where again corrosion can take place. Third type of oxide layer is volatile Volatile is nothing but like it can easily evaporate. So if the formed oxide layer is a volatile, it can easily evaporate and your metal surface again gets exposed to the atmospheric gases, where again corrosion can take place. See, if the metal oxide layer is volatile, the oxide layer volatilizes after formation and leaves the underlying metal surface exposed to the further attack. Fresh surface exposed to further attack. Next, the fourth one is porous oxide layer, where your oxide layer, your formed oxide layer will have a pores. Pores are nothing but holes. Okay, if your oxide layer is having a pores, again the atmospheric gases will penetrate through the pores and reach the metal surface by causing corrosion to the metal surface. So if the metal oxide layer is porous, the oxide layer formed has pores or cracks or holes. Okay. So in this case, atmospheric oxygen penetrate through the pores and corrode the underlying metal surface. This causes the continuous corrosion till conversion of metal into its oxide completely. So further attack through pores and cracks takes place. So next is the Pilling-Bitworth rule under the corrosion itself. Okay, this rule states that a specific ratio, okay, it's a volume of metal oxide to the volume of metal. That means this is your metal and this is your metal oxide. Volume of the metal oxide to the volume of metal. Why? The extent of protection given by the corrosion layer. It states or it explains the extent of protection. Okay, how this oxide layer is giving the protection by corrosion layer. Okay, and oxide is a protective or non-porous. If it is a protective, it will be non-porous. Like if we have a pores, again corrosion will take place. Now we are saying it is a protective layer. That means it is not having any type of pores or cracks. So hence it is a protective or non-porous. If the volume of oxide is at least as greatest as the volume of metal from which it is formed. Second type of chemical corrosion is corrosion due to other gases. So this type of corrosion is due to gases like sulfur dioxide, carbon dioxide, chlorine or the H2S or fluorine, okay, etc. The degree of attack depends on the formation of protective or non-porous, non-protective films. Okay, protective, or you can also call it as non-porous, and here non-protective means it is a porous on the metal surface. So we can explain this by two ways, by a protective film and the non-protective film. So if the film formed is protective, then the intensity or extent of attack decreases. It will decrease. If it is a protective, the extent of corrosion will decrease. If the film is non-protective, that means again corrosion will take place on the metal. So the extent of attack is increases. Okay, this is difference. Okay, if your metal oxide is protective, it will not allow further corrosion on the metal surface. So here your attack will be decreasing. Okay, so but here on metal surface, if your oxide layer is non-protective or it is having a pores, then the extent of attack is increasing. The extent of attack is increasing. Third type of chemical corrosion we have is liquid metal corrosion. That means a hot liquid metal is made to flow on the solid metal. Okay, so then the solid metal gets destructed or deformed. So this corrosion is due to the chemical action of flowing liquid metal at high temperature on solid metal. So the solid metal gets destructed. So that type of corrosion we call it as liquid metal corrosion. This is how a liquid metal will be looking like. So till now we have discussed the dry corrosion or the chemical corrosion. Okay. The next topic we have is other type of theory, wet corrosion or electrochemical corrosion. By the word it indicates it is a wet, means presence of moisture, or electrochemical corrosion. We'll see why we call it as a electrochemical corrosion. This type of corrosion occurs when a conducting liquid is in contact with metal. What we are saying, a metal when it is contact with the conducting liquid, then we call it as wet corrosion. That means metal is in contact with presence of moisture. This corrosion occurs due to the existence of separate anodic and cathodic parts. Remember the electrochemical cell which we have discussed in the previous sessions. Electrochemical cell will have two electrodes. One is your anode and the other one is cathode, which is dipped in electrolytic solution. So when two electrodes or when two dissimilar electrodes are in contact with the conducting liquid or the electrolyte solution, then electrochemical corrosion will take place, between which current flows through the conducting solution. This is how wet corrosion will be. So if you take an electrochemical cell which is having two dissimilar metals, that is, one is anode and the other one is cathode. So what happens at anode? Oxidation reaction is taking place. What do you mean by oxidation reaction? Loss of electrons. So near cathode undergoes the reduction reaction. So here gain of electrons. Now these two metals are connected through a electron flow, like these electrons flow from the circuit. Okay, and these two metals are in contact with electrolyte solution. So a basic thing, whenever anode undergoes the oxidation, it will lose its ions and electrons, and these electrons are consumed by the cathode. Okay, so in this process, what you have understood, anode is losing its electrons. It is losing, or it is giving off its electrons or ions to the other metal. So anode is becoming destructed. Anode is destructed, or anode is deforming. Can you see this? Okay, it is giving off its ions and electrons. That means it is getting destructed. So at anode, corrosion will take place. Okay, cathode is good. It is gaining its electrons. Whatever the ions and electrons, what is the cathode is having, it is not losing anything, but instead it is taking the electrons from the anode. But what is happening at anode? It is giving off its ions and electrons. So when it is losing its ions, when it is losing its electrons, the corrosion gets destructed or deformed. That means it is undergoing a corrosion. It is undergoing a corrosion. That is why we call it as a electrochemical corrosion. So at anodic area, oxidation reaction occurs, thereby destroying the anodic metal, either by dissolution or deformation of compounds. Hence, corrosion always occurs at anode. So whenever in corrosion or in electrochemical corrosion, if you see two parts, one is anode and the other one is cathode, remember corrosion always takes place at anodic part only, because anode undergoes the oxidation reaction. As it taking place oxidation reaction, it is losing of its ions. So it is getting destroyed or it is getting destructed. That is why we call it as electrochemical corrosion. It is a common type of corrosion which occurs usually in the aqueous corrosive environment. Now we'll see the next topic under electrochemical corrosion, that is mechanism of electrochemical corrosion. At anode, what is happening? It is losing of its electrons and it is consuming it. Whatever the electrons it is losing, it is consumed by the cathode. Now this consumption of electrons by reduction process, here reduction is taking place. So this reduction process, reduction means what? Gain of electrons. That means consumption of electrons that is coming from the anode. So this reduction can take place by two ways. One is evolution of hydrogen and the other one is absorption of oxygen. That we are going to discuss under the mechanism. So it is consuming the electrons that are coming from anode, that is nothing but reduction process, right? Now this reduction process can take place in any two of the methods. One is evolution of hydrogen or absorption of oxygen. So for explaining these two mechanisms, we are taking a best example, that is rusting of iron. Electrochemical corrosion involves the flow of electrons between anode and cathode, and the anodic reaction involves the dissolution of metals. So can you see the reaction here? So the metal undergoes the oxidation process and it gets converted into metal ions and the electrons. The cathodic reaction, what it does, it consumes the electrons with either evolution of hydrogen or absorption of oxygen. Now we'll see what do you mean by evolution of hydrogen and the other one is absorption of oxygen, by taking an example of rusting of iron. So the first mechanism is evolution of hydrogen. So this type of corrosion occurs in acidic medium. So by the heading or by the sentence, we are going to know it is giving the hydrogen, it is evaluating the hydrogen. So it should give the hydrogen gas, okay, evolution of hydrogen. That means we need to have something acidic medium that gives us the H plus ions. So considering the iron tank, okay, can you see a picture here now? We are taking this is iron tank. And it is having a small amount of impurity, that is copper, and the iron tank is covered by acidic solution. So what we are telling, we are taking a iron tank which is brown in color, and this iron tank is covered by acidic solution or the electrolyte solution, and on the iron tank we have a small amount of impurity, that is copper. As we know that when two metals, first metal is iron, the other metal is copper. When two metals are in contact with the electrolyte solution, it forms the electrochemical cell. So it is an example for a electrochemical corrosion. So what is happening now? We have iron tank right here and copper impurity, and it is covered by the acidic solution. So whatever the iron tank we have, that acts as anode, because see, coming to the galvanic series, when you observe the galvanic series, your iron will be on the top. That is why the iron will act as anode. So your iron will act as anode and copper is cathode. Copper is cathode. So as we know, anode means oxidation take place. Cathode means reduction take place. So we are taking iron tank that is covered by a acidic solution because we need a H plus ions to produce the evolution of hydrogen. So the electrons released from where? From anode, okay, flow through the metal from anode to cathode, whereas the H plus ions of acidic solution are eliminated as hydrogen gas. The anodes are large areas and the cathodes are small areas. So we have an iron tank and the iron tank will be now acting as your anode. That means it undergoes the oxidation process. What do you mean by oxidation process? Loss of electrons. So the iron will convert into a ferrous ions and the electrons. These two are your oxidation reactions. Now what is happening at cathode? The H plus ions, from where we are getting this H plus ions? From the acidic solution. So this H plus ions will consume the electrons, can you see the arrow here giving its electrons? It will consume the electrons and give you the hydrogen gas. It gives the hydrogen gas. This is your cathodic reaction. This is your cathodic reaction. What is happening at anode? First of all, oxidation. That means it is converting into a ferrous ions and electrons. Next, near cathode, the H plus ions from the electrolyte solution, will consume these two electrons to evolve the hydrogen gas. Now the overall reaction, if you see, the ferrous ions which are produced will diffuse into the electrolyte medium. Diffusion of ferrous ions formed into the electrolyte. That means the ferrous ions formed will diffuse into the acidic solution and it gives you the overall reaction as, see, ferrous and the H plus ions gives you the ferrous ions and the H2 gas, hydrogen gas. This is how evolution of hydrogen takes place. Next, we have other type of mechanism that undergoes near reduction is known as absorption of oxygen. So this type of corrosion takes place in the basic or neutral medium in presence of oxygen. Okay, here we are using a electrolyte solution, that is aqueous neutral solution or alkaline solution in presence of the oxygen. So again we are taking an example of iron tank. Now imagine iron tank is covered by a thin oxide film. This one, thin oxide film. If by some means of any attack or any stress, if the oxide film is removed, or like, can you see any a crack or it is a broken, if your oxide film, whatever it is formed on your metal surface, by means of any attack it is cracked or broken. Now you can see two parts in our module. Okay, so what are those things are? One is the metal covered by oxide film. Oxide film. And second one is not covered by oxide film. So whenever you see a crack on the oxide film on the tank, now you can have two parts. One is a tank or the iron which is covered by oxide film or the iron which is not covered by oxide film. Now, the iron metal which is covered by oxide film, we take it as cathodic area. Cathodic area. Now, the iron tank which is exposed to the atmosphere or which is not covered by the oxide layer, it's a small amount of area, that is anodic area. That is anodic area. And now this is covered by a aqueous neutral solution or alkaline solution. Anodes are small here and the rest of the metallic parts are the large cathodes. So if you observe, near anodic area, the small area which is exposed to the atmosphere or the environment or the electrolyte solution, the small area undergoes the corrosion and it gives you same like ferrous is converted into ferrous ions and electrons. Coming to the cathodic area, it undergoes the oxidation. That means the oxygen present there will consume the electrons, in presence of water. Like with the help of water, it gives you hydroxyl ions. Understood the cathodic reaction? The oxygen present there will consume the electrons from the anode. With the help of water, it produces the hydroxyl ions. Now, the hydroxyl ions which are like a ferrous ions which are not unstable will again combine with the hydroxyl ions and give you the ferrous hydroxide twice. Now this will again react with it. Now this is an unstable one. It reacts with the water and oxygen to give you a yellow rust. This is how a rust formation takes place in the absorption of oxygen. So ferrous ions and OH minus ions. You can see here ferrous ions and OH minus ions combine to form a FeOH2 taken twice precipitate. Now if enough oxygen is present, ferrous hydroxide is easily oxidized to ferric hydroxide. This is how your rust is formed in the absorption of oxygen. Now, as here, cathodic area is large, so corrosion takes place more. Corrosion is more. In previous evolution of hydrogen, here cathodic area is small. Cathodic area is small, so corrosion is less. Corrosion is less. Why corrosion is taking place? Because the cathode is gaining its electrons, like it is taking the electrons from the anode. So if our cathodic area is small, the amount of electrons it wants only it will take, so corrosion is less. So if your cathodic areas are large compared to anode, then the corrosion is more. So till now we have discussed the corrosion, causes and effects of corrosion, and also the theories of corrosion we have discussed, that is dry corrosion and wet corrosion. Thank you.